Okay, so we're starting 11.5, adding, subtracting rational expressions. This is part A, LCM and LCD. So recall that the least common multiple, LCM, of two integers or more is the smallest positive integer that is evenly divided by both or all integers. Okay, so keep that in mind. Now, we're not just working with integers here, we're working with polynomial expressions. So the steps to find the LCM of polynomial expressions goes as following. 1, we're going to completely factor each expression. 2, find the prime factorization of all the numbers that are factors, numbers outside the parentheses. 3, the LCM is the product of the prime factors and factors each raised to the greatest power that they are. And then step 4, we're going to simplify. So let's go through the steps on example number 1. So step 1 is to completely factor the expressions. So we're going to completely factor each expression. So completely factoring 4x squared, I can take out my greatest common factor, which is 4. That leaves me with x squared minus, that is not 16, 9. I have no clue why I wrote 16. X squared minus 9. And now I'm down to difference of two squares. So this is a dot situation. So remember dots, I'm in my mind asking myself, what is square root of x squared, square root of 9? So that gives me 4, x minus 3, and x plus 3. Okay. And now I'm going to factor 6x squared plus 36x plus 54. Factor out the GCF, which is 6. Leaves you with x squared plus 6x plus 9. I have a simple trinomial. So what multiplies to give me 9, but adds to give me 6. So that leaves me with 6 times x plus 3 times x plus 3. All right, so step 1, done. Step 2 is to find the prime factorization of all the numbers that are factors. So 4, we're going to write this in prime factorization. Remember, 4 is 2 and 2, right? So this becomes 2 squared times x minus 3 times x plus 3. 6 in prime factorization. 6 is 2 times 3. So this becomes 2 times 3. And we have x plus 3 squared. All right. So now to find our LCM. So the LCM is the product of the prime factors and factors each raised to the greatest power. So what that means is that I have a 2 as a factor here, and I have 2 as a factor here. I want the power, I want the one with the highest power. So 2 squared is what is going to make up my LCM. So 2 squared. Now I'm going to look at the next factor I have. I have 3. Well, there's only one 3. 3 to the 1 power is the only one I have. So 2 squared times 3 to the 1 power. Then I have x minus 3. X minus 3 is the only factor of its kind. So x minus 3 is going to represent. And then I'm down between x plus 3 to the 1 power and x plus 3 squared. It says that we're going to take the factors that are raised to the greatest power, right? So therefore, we're going to use x plus 3 squared. X plus 3 squared. So this is my LCM in its factored form. And so my LCM in its non-factored form would be 4 times 3 is 12. So we'd say 12 x minus 3 x plus 3 squared would be the LCM. Okay, let's try those steps again. So 1, we factored our expressions completely. 2, we wrote our numbers in prime factorization. 3, we used the prime factors and factors each raised to the greatest power to find our LCM. And then 4, we simplified our LCM. Okay, so let's try that again. So step 1 is to factor completely. Everything is already factored completely, so factored, check. Step 2 is to write our numbers in prime factorization. Well, this number is 1, so it's good to go. This one is not in prime factorization, so it becomes 2 times 5. Done. Step 3 is to look at your factors and prime factors and use the greatest power of each one. So for 2, it's the only one, so greatest power is LCM equals 2. 5 is the only one, so greatest power is 5 to the 1. X minus 2 is the only one. Okay, it's basically like you want to make sure that someone is representing each factor family. And then between x plus 3 and x plus 3 squared, x plus 3 squared is the greatest power. So my LCM, simplifying it, the LCM equals 10 x minus 2 times x plus 3 squared. And that's my LCM. All right, so now we're going to talk about the LCD. So least common denominator, LCD, is the same thing as an LCM. We're just emphasizing the fact you're only finding the LCM of the denominator of a rational expression. Okay, so what do? We rewrite the rational expression so that they have the same denominator, is what we're trying to do, is our goal. That should be after this. But anyways, so the steps. First, we're going to find the LCD. Again, it's the same thing as our LCM, except we're only looking at the denominator of the rational expression. We're going to divide the LCD by each denominator. Basically, figure out what would you have to multiply denominator by to equal LCD. And then 3, we're going to multiply the numerator and denominator by the quotient from step 2. And then we will have 2 fractions with the same denominator. So here, LCD, so we're focusing on the denominator. So we have x squared y and 2xy. So between these two, they're already basically factored in prime factorization, right? So looking at them, step 1, our LCD is going to equal the greatest power of each factor. So 2 is the only one, so it has to be 2. I have x squared and x squared is greater. I have y and y, it's only 1y. So my LCD is 2x squared y. Okay. Step 2 is to divide the LCD by each denominator. So if I have 2x squared y divided by my first denominator, x squared y, that equals 2, right? If I take 2x, the LCD, 2x squared y, and divide by my second denominator, 2xy, that leaves me with x. Okay, step 3 says to multiply the numerator and denominator by the quotient from step 2. So I'm going to multiply the numerator and denominator of these fractions with the quotients from step 2. So with their respective quotients. So for 6x minus 1 over x squared times y, I'm going to multiply each one times 2. So numerator times 2, denominator times 2. And this is going to give me 12x minus 2 over 2x squared y. Okay, now I'm going to do the next one. So I have 3y plus 2 over 2xy. The quotient that I got from dividing by the LCD by the denominator was x, so I'm going to multiply numerator and denominator by x. Got to keep it balanced, and that gives me 3xy plus 2x over 2x squared y. So now what it wanted me to do was to rewrite the rational expressions so they have the same denominator. I rewrote the rational expressions so they both have the same denominator. Okay, as you do this, you build other skills, you recognize patterns, and it goes a little faster, and you also can do a little more mentally. Let's try it again. So step 1 is to find the LCD, so that we focus on the denominators. So in order to find the LCD between these two, we're going to have to factor. So using the same steps for LCM of expressions, we're going to factor and then find their LCD. So factoring my denominator, this is simple factoring, what multiplies to give me 12, but adds to give me -4, and this is GCF. So I end up with x minus 6 times x plus 2. And on the other one, I factor out 4, and I'm left with x plus 2. So the LCD is what do they have? So 4, it's the only 4. So I can write it in prime factorization, which would be 2 squared. X plus 2, we each have only 1. And x minus 6 needs to be represented. So my LCD is 4 times x plus 2 times x minus 6. Step 2 is I'm going to divide each denominator by the LCD by each denominator. Now, since you already factored it, it's best to use the factored form for dividing. So for this one, the first one, I have 4x plus 2 x minus 6 divided by x minus 6 times x plus 2, and that gives me 4. Then I'm going to do the next one. So the next one, I have 4x plus 2 times x minus 6 divided by 4 times x plus 2. Leaves me with x minus 6. Okay, so now step 3 says I'm going to take the factors, take the quotients and multiply them to their respective rationals. So I have 1 over, and I'm going to, again, once I factored, I'm going to focus on using the factors the entire time, okay? So I have 1 over x minus 6 times x plus 2, and I'm going to multiply the numerator and denominator by the quotient that I got, which was 4. So I'm going to multiply, didn't mean to make it that large. The numerator times 4 and the denominator times 4. And that's going to leave me with 4 over 4 times x minus 6, x plus 2. Okay, now I'm going to do it to the other expression, the other rational expression. So we have 3x over 4 times x plus 2. And I'm going to multiply the numerator and denominator by the quotient that I got in step 2. So we have 3x times x minus 6. And we have 4 over x plus 2 times x minus 6. Once I do that, Notice here how they now have the same denominator. So both expressions have the same denominator. Yay, LCD. All right, it's going to take practice, but we're going to utilize this a lot when we are adding and subtracting rational expressions. Stay tuned to part B.